Hi, welcome back to my class. Today I'm going to explain the Chomsky hierarchy of languages. So, what do you mean by Chomsky hierarchy? Here, Chomsky is a scientist name. Okay, according to him, his name is Noam Chomsky. According to him, there are four types of grammars or languages, we can say. He divided all the available grammars into four different types. So we know those grammars can produce the languages. Okay, means there are four languages, and those languages can be accepted by automaton. So there are four types of automaton. So total number of grammars are four. Those grammars are producing languages, four different languages, and those languages can be recognized through automaton. Okay, so what are those four languages? What are those four grammars, and how which machines are recognizing those languages? We will see. So according to Noems, there are four types of grammars I have explained: type 0, type 1, type 2, type 3. So there are four different grammars or four different languages. So what is type 0? So type 0 is unrestricted grammar because this is superior among all the grammars. So type 0 has no restriction in grammar rules. What do you mean by grammar? Set of rules. Okay, every grammar is having set of rules. Here we are going to show the rules as left side term implies right side term. Like that, we show the rules. Now we will see what are the rules in type 0, type 1, type 2, type 3. So first we should know what is type 0. So type 0 grammar is unrestricted grammar because it is not having any restrictions at left side part as well as right side part. So this unrestricted grammar is producing recursively enumerable language. Whatever the language it is produced by unrestricted grammar, that language name is recursively enumerable language. So that language can be recognized through Turing machine. We have so many types of finite automaton. So this is one of the machines, that is Turing machine. This is superior machine. Turing machine recognizes recursively enumerable languages which are produced through unrestricted grammar. That is type 0. So what is type 1? Type 1 is somewhat little compared to recursive, unrestricted grammar. This is having some restrictions. So type 1 grammar is called context sensitive grammar. So this context sensitive grammar is producing context sensitive language. So this language can be recognized through linear bounded automaton. The automaton name is linear bounded automaton. And the type 2 is context free grammar. So this free in the sense is a free at left side, right side part, not at left side part. But in unrestricted grammar, the total grammar rules are free at left side as well as right side part. But in context free grammar, free in the sense we can take any number of terminals and non-terminal symbols at right side part. Terminal means lowercase letters and non-terminal means uppercase letters. Okay, so type 2 is context free grammar which produces context free language, and this particular language can be recognized by push down automata. So push down automata can recognize context free languages. And type 3 grammar has more number of restrictions compared to above grammars. So that type 3 grammar is regular grammar. This regular grammar is producing regular language, and finite state machine or automata is used for recognizing regular language. So finite state automation means either deterministic finite automata or non-deterministic finite automata, means DFA or NFA can recognize regular languages. So these are four types of grammars, languages, and the machines which can be recognized by recognized, or the language which recognizes all the languages. Okay, so this is according to Noems. Now we will see what are the set of rules for type 0, type 1, type 2, type 3. We will start with type 3 because type 3 has more number of restrictions. Somewhat context-free grammar has less number of restrictions compared to this, and the context-sensitive grammar has less number of restrictions compared to this, and recursively enumerable language has no restrictions. That's why we call it as unrestricted grammar. We will see one by one now. So what is type 3 grammar? What is type 3 grammar? So type 3 grammar is regular grammar. Type 3 grammar is regular grammar. So this regular grammar is producing regular languages. So those regular languages are recognized by finite state machine or automata, either this deterministic finite state machine or non-deterministic finite state machine. Both can recognize this type 3 grammar. Okay, but what are the restrictions in grammar rules? Grammar rule means we are supposed to use left side part some symbols, implies right side part some symbols. Then what is the restriction in type 3 grammar, we will see. Okay, so the production must be, because grammar rules are written in production rule format. So here the production rules are one non-terminal should be there at left side part, and right side part either one terminal or one terminal followed by one non-terminal. This is the restriction. Either you write capital letter implies small letter, or capital letter implies small letter followed by capital letter. This is only the rule. If any grammar is there in this form, we can say that this is regular grammar. Very restrictions. Okay, we cannot write two terminal symbols here. We cannot write two non-terminal symbols here. Either we write the right side part, we write one terminal symbol. Terminal means lowercase letter, or we write one terminal followed by one non-terminal symbol. Non-terminal means uppercase letter. So X and Y belong into non-terminal set. N, capital N means non-terminal set, and small a is belonging to T means terminal. Just we are given these two names for recognizing or remembering purpose. Capital N is non-terminal symbol set. Capital T is terminal symbol set. Okay, but sometimes we may use epsilon at right side part, but here we cannot use epsilon at right side part if S is appearing at right side part. If means symbol, starting symbol, if starting symbol is appearing at right side part also, we cannot use it. This becomes invalid if X implies a capital X. If X implies a capital X is there, then X implies epsilon is invalid, because we cannot use this particular production rule if X is also appearing at right side part. If X appears at right side part, this particular production rule becomes invalid. Otherwise, we can write, because X implies epsilon is production rule. Right side part, there is no epsilon appearing. Then all the production rules are following this syntax. X implies either small a, or X implies small a followed by capital Y. So capital Y implies small b, or we can write small b followed by capital Y. So like this we can write. So if any grammar rule is following these particular syntax, then that grammar is called regular grammar. So very simple grammar, One terminal or one terminal followed by one non-terminal should be there at right side part, and left side part one non-terminal symbol should be present. Then only we treat it as meaningful production rule. So this grammar is called regular grammar. Then type 2. What is type 2 grammar? Type 2 grammar is context-free grammar. This context-free grammar is producing or generating context-free language. I told you already, free in the sense free at right side part. Left side part, non-terminal should be there. Right side part, group of terminals and non-terminals, means T union N whole star. Gamma, A implies gamma or alpha or beta, you can write. A implies alpha or A implies beta or A implies gamma, you can write. A belongs to non-terminal set, non-terminal symbol set, but gamma belongs to terminals as well as non-terminal symbols. String of terminals and non-terminal symbols. Okay, na? So there is no restriction at X, because X can or S can present at right side part also. Then we can use X implies epsilon. Only condition is this production, only simple production format. Left side should be one non-terminal symbol must be present. Right side we can use any number of terminals or non-terminals. In star means epsilon also allowed. Okay, na? S implies XA, or X implies A, X implies AX, X implies ABC, because terminals and non-terminal combination, we can use all the terminals, or we can use all the non-terminals, or we can use group of terminals as well as non-terminals. So type 2 grammar is context-free grammar, which produces context-free language, and the format of this is, or all the production rules format is A implies gamma. You can take not only A, you can take any capital letter here, followed by either alpha, beta, gamma, or any other symbol. But that symbol should be string of terminals and non-terminal, and the symbol, left side symbol should be non-terminal symbol. Okay, right side is string of terminals and non-terminal. Either you use only terminals, you use only non-terminals, or we use combination of terminals as well as non-terminals like this. A capital X capital Y, or A capital X capital Y, like this we can use, but there is no restriction using X implies epsilon. Even X implies X is appearing at right side part because it is free. Right side part, we can also use X implies epsilon. Okay, so this is type 2 grammar. Then what is type 1 grammar? So type 1 grammar is context sensitive grammar. Context sensitive grammar. This grammar is generating context sensitive language. Then format is alpha, A, beta, means this is non-terminal symbol. So before non-terminal symbol, we can consider any number of terminals and non-terminals, means string of terminals and non-terminals. After this non-terminal symbol, we can also consider any number of terminals and non-terminal symbols at right side part. So right side part, we can use terminals and non-terminal combination, but at least one non-terminal should be there. Even alpha and beta both may be epsilon, nothing wrong. Okay, and alpha A beta implies alpha gamma beta. Alpha gamma beta. See here, alpha beta, alpha beta. Here A is there in between alpha beta. Here gamma is there in between alpha beta. So gamma, alpha beta gamma are string of terminals and non-terminals. Even alpha beta is empty, means epsilon. Here A should be present. Even alpha beta is epsilon. What is gamma? String of terminals and non-terminals. So we can take any group at right side part. Even alpha beta are empty, means epsilon. Left side should present at least one non-terminal symbol. That is the condition. So left side one non-terminal should be present, though alpha beta are empty, or even alpha beta, or you can consider alpha beta as epsilon. A should present. Here alpha beta is epsilon, gamma should not be empty. So gamma should contain at least one terminal or one non-terminal. Gamma is also string of terminals and non-terminals. It can be one terminal, or it can be one non-terminal, or group of terminals and non-terminals. Okay, so this is a syntax of each and every production rule in type 1. Alpha A beta implies alpha gamma beta. Alpha beta gamma are string of terminals and non-terminals. Okay, na A is non-terminal symbol. A is non-terminal. See, these are the examples. Okay, na 1A may present means alpha beta is empty. Even alpha beta is empty, gamma may be group of terminals and non-terminals. Here also, if B means capital letter, B means capital letter, non-terminal symbol. Capital letter implies only gamma contain non-terminal symbol, or non-terminal symbols implies terminals and non-terminal combination. Any grammar syntax it allows. Any grammar syntax it allows. So left side one non-terminal should be present. Right side any number of terminals and non-terminal combination we can take. Any string of terminals and non-terminal symbols you can take, but you have to remember the syntax. Okay, now this is type 1 grammar syntax. Then what is type 0 grammar? Type 0 grammar is unrestricted grammar. There is no restriction at left side part as well as right side part. So any number of terminals and non-terminals we can take at left side part. Any number of terminals and non-terminals we can take at right side part. Okay, na? So see type 0 grammar. So this type 0 grammar is unrestricted grammar. This grammar is generating language. That language is called recursively enumerable language. The productions have no restrictions. That's why we treat it as unrestricted grammar. Okay, na? So structure of the grammar is alpha implies beta. Structure of the grammar is alpha implies beta. So alpha cannot be null because left side one symbol should present. Alpha is a string of terminals, non-terminals. Beta is also string of terminals and non-terminal. Okay, na? But at least one non-terminal should be there. Okay, na? At the left side part, alpha should not be empty. Alpha should not be empty because there is no meaning of production rule. Suppose implies ACA, suppose S is not there. Implies ACAB means there is no meaning. Implies means left side we should have or at least one non-terminal symbol, right side any combination, right side any combination. So that's why alpha is of course set of terminals and non-terminals with at least one non-terminal symbol, at least one non-terminal symbol. And right side part you can take any number of terminals and non-terminals. See here S, B, C, C, B, A, D, A, B, C, A, B, C, D, E, D, any combination you can take, any combination you can take. Right side also you can take any combination. But please remember left side part at least one non-terminal should be present. Otherwise there is no meaning in grammar syntax. So this type 0 grammar is unrestricted grammar. It is superior grammar than all the remaining grammars. Okay, na? This grammar is producing language called recursively enumerable language, and this particular language is recognized by Turing machine. Turing machine, I told you already in diagram. Okay, so this is about Chomsky hierarchy of languages, because Chomsky proposed or divided all the languages into 4 different categories. Okay, so thank you for watching my video. Thank you so much. Thank you.